Testing another engine tonight. This is the one from last static fire, and we said in our conclusion we wanted a slightly shorter engine, so we got a half an inch shorter in order to reduce some of the popping we were getting, and also we wanted a decrease in the throat diameter. So we went from 7/8 down to actually 5/8 here. You'll notice this severely melted plate or kind of raft at the bottom of the engine. We just do that to make it easier to 3D print because the printer will knock it over if it doesn't have a raft to stand on. And we don't cut it off because it acts as a heat shield as the flames are coming up from the torch. So it preserves the rest of the engine, the important part, while sacrificing a little bit of that extra plastic. The testing with this one showed even more popping, or maybe significantly more, because we also increased the feed pressure. Last night we only went up to about 25 psi. Tonight we took it to 35, and we saw some blue flame as we were adjusting the air fuel ratio a little bit, but still. Also, I think last night this one, it was popping but not sustaining, which means it will pop and the flame stops and you have to reignite it. This one, curiously, was popping, but it was still sustaining the flame, so it would pop, 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 but fire was still coming out. And we think we've made progress in the right direction. The popping is caused by at any point in time, not enough propellants in the chamber. So say it all ignites and then blows itself out the bottom, well then there's nothing left in the chamber to continue the combustion. So we're going to try to decrease that velocity of that popping by opening the chamber, or opening the throat diameter to 3/4 inch and decreasing the chamber volume slightly. When you have a large chamber volume, when it ignites, all that fuel kind of ignites at once and it creates a really big boom, which in our case, we don't want one big boom, we want a sustained explosion. And so we're going to try a little smaller chamber volume and just open that up a little bit. So I'm holding 3 engines. This is 6, this is number 7, and this one's number 8. So we decided to put number 6 back on the stand tonight and just try it, but at higher pressure, and we pretty much like what we saw. It wasn't popping because it's got this, look at the nozzle, or the throat diameter is much larger. And the fire coming out the bottom wasn't very focused, but it was sustaining pretty well. So we think we might need a compromise now between the short stubby chamber and the big nozzle and the little nozzle and the long chamber. So all these variables, we're starting to hone in on what makes this thing work best. So at some point we want to be able to measure how much pressure is built up inside the chamber, and to do that I have a barbed fitting that will spin into where this plug bolt is, and then it goes to this it's like a water column meter. Basically it's a loop of pipe. It starts here, comes down, comes back up, and then we put water in it. And the water line is about where this tape is. And whenever the engine pushes hot gases out the pressure takeoff, it will push the water down on one side and it'll go up on the other, and we can measure how many inches of difference, and that'll give us a PSI reading. Now you might wonder why not just use a pressure gauge. Well, the gauges we have here are like in the range of 100 PSI or maybe 20 PSI, but we are expecting 1 or 2 PSI of chamber pressure. 1 or 2 PSI will get us about a half a pound of thrust, which is actually plenty enough for a small model rocket, and the 1 or 2 PSI won't even register on the gauges we have. So the next revision, we're going to try to address that severe popping and get a more sustained burn, but a more aggressive burn. We are overall still pretty pleased with the fact that we can print these engines, even though the bottoms of them are melting off. The insides really are still in great shape. This engine's still usable, so good for rapid prototyping.